Winston, great to have you.
Thank you for including our paper.
You probably already count as a frequent presenter or a frequent participant at least, and great to have you back. Everybody sees everything that's relevant. So Winston, the floor is yours for the next 20 minutes. Please go ahead.
All right, thank you so much, Christian, and other organizers to include our paper on this program. The paper is jointly with Yan Ji from Hong Kong University of Science and Technology, and Tian, who is a student at Penn Econ. He will be on market next year. He's an excellent job candidate. Please pay attention to him. And also with Pengfei Wang from Peking University. The title of the paper is Asset Pricing with Misallocation. It's quite straightforward paper. We'll have a big part of the paper will be on macro theory and have important implications on asset pricing. And also we will also provide asset pricing tests and empirical support. So for the past decades in the macro literature, people already show that misallocation is so important. It not only shapes the TFP levels, but also it is one of the major driver of economic growth. And at the same time, for the past decades in the asset pricing and microfinance literature, people find the low frequency growth play a crucial role in asset pricing. So naturally, this misallocation, if we put these two pictures together, you'd imagine misallocation should be important for asset pricing, for capital markets. But in the literature of so-called long risk, the empirical evidence regarding this channel is still controversial. One, because this dark matter feature emphasized in John Campbell's lectures and textbook and my recent papers. The reason is this low frequency component in the aggregate growth is so hard to be identified just using fundamental data, and also which make this question problem worse is it's hard to find instruments that help us to predict this low frequency growth using other sources of data. At least we don't have such guidance yet. So this paper tried to fill this gap. We first built a model. We show that misallocation actually is a major driver of the low frequency aggregate growth through its impact on R&D intensity endogenously. So that's all this paper about. This logical chain is quite natural. It's just how we execute this. Before moving to details, let me summarize the three major contributions of this paper. As I said, the first major contribution is we develop analytically tractable GE models with heterogeneous firms. It's not an easy task. And beautifully, I would call this beautifully, in this model, the misallocation, which summarizes the joint distribution of firms' productivity and their capital allocation, will emerge analytically as a k-state variable and capture the dynamics of this general equilibrium of the economy. And we show, actually, we use one approximation method to deal with this so-called Kuto-Smith problem. Usually in macro literature, in microfinance literature, when people facing this kind of heterogeneous firms, you need to track this infinite dimensional joint distributions. That's a headache for researchers in those fields. In this model, we design a model and provide an approximation to tackle this, to convert this into almost analytical problem. And we show that misallocation in the model and in the data can help explain asset returns as a powerful macro factor. And also, very strikingly, the performance of this misallocation factor is comparable to Farmer-French three-factor models. So to asset pricing people, microfinance people, actually, this is definitely non-trivial result, because we know, it's really hard to find some non-treatable macro factor, interpretable macro factor that can be, have performance comparable with those reduced formed like 5 French or 3-factor or 5-factor models. But here I'll show you actually this misallocation is very powerful microfactor. And more importantly, as our model suggested, and we show in the empirical analysis, this misallocation factor will actually subsumes this accumulated future consumption growth, which has been used as a proxy for the long run risk. You know, once you add in this factor, this accumulated future consumption growth doesn't have, you know, additional power to explain the cross-section of asset returns. And the last contribution is in the theory, we show actually this aggregate persistence parameter of this aggregated economic growth, which is the dark matter, right? We know in the in Amir and Ravi's paper, this has to be 0.975 or 0.98. It's hard to identify using the aggregate data, but in the theory, we show that parameter endogenously connected to the persistence of the idiosyncratic TFP. This makes this dark matter not so dark anymore, because now we have a vast panel of firm level productivity data to help us to identify that parameter. Of course, if you believe this model we build up, this mechanism we build up. Okay, so now let's jump into the model. So the model actually, in our model in the economy, there are 3 sectors, just like Romer's endogenous growth model. There's an R&D model. There's an R&D sector. This sector is kind of like inventors. They're producing blueprints using final goods. And why in this economy we need blueprints? Because there's another sector, this intermediary goods sector. They need to have using these blueprints to gain market power to produce, you know, this differentiated goods, intermediate goods, and sell to the final goods firms to produce like consumption goods. So there's a final goods sector who will buy the intermediary goods from the intermediary goods sector, and together with capital, labor, they will produce final goods like cars, clothes, and so on. But importantly, the key deviation in our paper relative to the standard Romer's model is, later I'll show you, the final goods sectors, the firms, they're not homogeneous anymore. And the capital allocation, reallocation is now efficient because they are facing financial frictions, equity market frictions, and debt market frictions. And in this model, actually, it's very simple in the sense we only have one aggregate shock. You can think it's like business cycle shock. And also each firm also subject to a firm level idiosyncratic productivity shock. So pretty standard. So now let me first introduce how, you know, the final goods sector works. In this sector, we have continuum firms, but they're heterogeneous in the firm level productivity and the firm level capital. And this joint distribution is captured by this var T A of Z. And this, importantly, this var T as an endogenous variable will be driven by the aggregate shocks in the economy endogenously, and will shape this other decision variables in the economy. And each firm, they are facing this constant return to scale technology. You can say that a bunch of things. Let me actually quite standard. So first, they need to have this XIT, which is like intermediary goods to produce final goods YIT. And this intermediary goods is aggregation, CS aggregation of different intermediary goods produced by different firms in the intermediary goods sector. And this new captures market power of the intermediary goods sector, intermediary goods firms. And this capital NT is a stock of knowledge. You can think it's like an intangibility in this whole economy. If this NT is bigger, the intangibility is bigger, larger in this economy. And now the firm to produce this final goods, the firm not only need to buy this intermediate goods XIT, but also need to hire laborers at this competitive wage, WT, and also need to use capital. And the capital, they can use their own capital in stock, which is AIT, And also they can lease, they can borrow capital from other firms, which is AIT hat. So you put them together, this is KIT is like effective capital the firm I use to produce in period T. And this UIT is variable utilization, is between 0 and 1. The more they can choose this freely. So basically, if UIT is bigger, they need to pay more cost to, to kind of like maintain the machines. Otherwise, the machine will depreciate faster. And
10
also,
minutes, Winston.
Okay, I need to move faster. So this depreciation rate is, have some randomness. And this firm level productivity follow this AR1 process. And the firm's capital itself, AIT, also, follow depreciation and subject to this aggregate capital shock, and the firms will make endogenous investments. And the intermediary goods sector, they're continuum firms, but now it's homogeneous. So each one indexed by J from 0 to capital NT, and they are facing this kind of like a demand, downward sloping demand curve, generated from the final goods sector. And they have this kind of monopolistic power. So they just choose this P price optimally to maximize the profit. And the value of this monopoly captured by this blueprint owned by this intermediate goods firm. So let's call this VJT, which is marginal value of the blueprint. So the blueprint actually has this claim. It is a claim to all this kind of like this profits generated by this intermediate goods sector. So we can satisfy this Euler equation. And this lambda T is the endogenous SDF we're generating this model. And the R&D sector, actually, they have the bargaining power relative to the intermediary goods sector. So what they're doing is they just sell the blueprints at exactly the marginal value of the blueprints. That's what big, in other words, they capture all this profits, value added by the blueprints. And we also assume the R&D firms are homogeneous. So in the equilibrium, this value for each blueprint will be identical to each other in the symmetric equilibrium. So all equal to this. And given this marginal value of the blueprints, this R&D sector will calculate how much of each period, how much additional blueprint they will create. So increase this knowledge stock NT. And this ST is their choice variable. And this is varthi theta T is captured the marginal productivity. It depends on the existing stock, which is a spillover effect, and captured by, within this period, in aggregate, how much additional blueprints will be created. So this capital ST, this capture, why this in the denominator is trying to capture the so-called conjunction effect. So it's like this competition effect. And because this guy has market power, they have this free entry condition in terms of like how much they were going to produce. So the marginal return, they will produce up to, this free entry condition is reached, which means the marginal return of produce one additional unit of blueprints, which is VT, marginal value, multiplied by this theta T, which is marginal productivity, equals to 1, because the cost for produce 1 unit of blueprints is 1 unit of final goods. So this is a free entry condition. So this is how R&D sector works. And now agents, we have workers and the managers. They are identical, have recursive preferences. They can perfectly share risk. And each manager controls and operates the final goods firm and gaining rents tau times AIT. And here, because of time, I cannot go to details, but we can endogenize these two financial frictions. One is the equity market constraint, which means the manager has to pay out each period this rho times the AIT to the shareholders. And also the how much they can borrow lease from capital from other firms. This AIT head is upper bounded by is bounded from the above by lambda times AIT. It's like the standard collateral constraint. So because of these two financial constraints, you can see that's why this AIT cannot immediately reallocate from low productivity firms to high productivity firms. That's the key thing. And given this, the agent will maximize the present value of the rents, and according to that, they will choose the firm level decisions optimally. And it looks like a very complicated problem. There are 4 choice variables. They need to decide this utilization, the amount of capital they're going to lease, the labor they're going to hire, and how much of the intermediate goods they're going to buy. Actually, because in this model, 5 minutes. Okay, it actually, we have this linear and band solution, which means there's an equilibrium cutoff for firms whose firm level productivity higher than this. They will fully utilize. Otherwise, they will shut down the firm and rent out lease out their capital to other high productive firms. And so that's why this effective capital used by the firm, KIT, is also this, and reach the upper bound how much they can get. Otherwise, they just shut down and lease out all their capital. And at the same time, if they are producing, the amount of labor they're hiring in the equilibrium follow this. You can say it's very important because that's why we need constant return to scale. This is a basic linear function of productivity, utilization, and the capital. The same thing for this intermediate goods sector is linear. That's why later we can do the aggregation easily. Otherwise, the aggregation will be almost mission impossible. So because of this, we can do the aggregation at the aggregate level as if there's a representative big firm, producing the final goods YIT or YT, and the aggregate productivity is endogenous, follow this, depends on this cross-sectional distribution of the capital and productivity. And also this optimal cutoff point, which firm will start to produce, which firm will stay put and run out of the capital will be pinned down by the market clearing condition in the capital markets by this equation. And okay, it looks like a super complicated problem even here because we need to track this infinite dimensional state variable. But here we play a trick. So actually the endogenous capital we can prove in the cross section, they almost follow a log normal distribution. They are not going to exactly follow this, but we can prove they were always getting closer to this. And if we just assume it will reach this long run log normal distribution and we plug into the system, suddenly this cross-section distribution have this parametric functional form. That's good because we convert this potentially infinite dimensional problem to a finite dimensional problem. And more importantly, this misallocation capital empty shows up as one very important parameter to characterize this cross-sectional distribution. And what's this misallocation? It is like covariance between in the cross-section between this productivity and asset allocation and divided by the variance of this cross-sectional log productivity. And given this, the economy can be characterized by these 3 endogenous state variables, aggregate capital, aggregate stock of knowledge, and the misallocation. And misallocation follow this endogenous process. And any aggregate shock will shock on this part, and it will endogenously affect MT. And MT follow a very persistent parameter if this theta close to 0. So very importantly, in this equilibrium, you can see after we solve the model, this aggregate productivity level is negatively related to this misallocation. And because of this, and R&D intensity in the economy is also negatively dependent on this misallocation in the economy. And here we show like impulse response. Suppose we have a negative shock to the misallocation, which is a good shock. And let's look at this red curve. So this consumption level will gradually increase to some new steady state. And you can see this marginal growth rate, which is long run risk. First jump up, but spend a long time to converge back. That's what we call long run risk. Okay, this is actually how we generate long risk. That's why misallocation matters. So this is like a recap of the model. Let me just describe this line. The logic of the model is quite intuitive. When misallocation is high, the average productivity in the final goods sector is low. So the marginal value of this patent to produce intermediary goods will be low. And then R&D will be low. When R&D is low, the economic growth endogenous will be low. That's it. So empirical, based on this measure, very simple covariance measure. So we just, in the data, we measure this asset of each firm, and we measure its productivity of firm I. We just run this cross-sectional regression. That we got this beta. And this beta, we use negative beta, we use this as misallocation measure empirically. So it will look like this. So the big important thing is this misallocation measure is highly countercyclical. And now we say, whether this misallocation measure in the data can predict R&D intensity in the economy. So we focus on different samples, a period. Actually, yes. Well, contemporaneously and 1 year ahead, they all negatively, significantly predict the R&D intensity, and also whether they can predict consumption growth for the long run. If you look like 4 year ahead, 5 year ahead, yes, the predictability will be significantly negative, and across different sample periods. And the same thing for output growth, just like the model predicted. And lastly, most importantly, you can see this asset pricing power. So this panel A is a CAPM. So we have the standard like 44 portfolios, bonds and different portfolios. You can CAPM totally fail. And if we add on CAPM, just add on this misallocation factor, the power is big, is obvious, very significant. And this is a French 3-factor. You compare this two plots, maybe our 2-factor model even looks better. And lastly is the table. So, I show you some numbers. So this column is market plus our misallocation factor, 2-factor model. You can see the misallocation is significantly priced. And if you compare this total pricing error between our 2-factor model and the French 3-factor model, they are pretty close. And also, this column is go to this Johnson Parker's JP paper, basically replicate. This is same means the future cumulative consumption growth, right? Try to capture the long run risk. And you can see, yes, consistent with their paper, it's significantly priced. But once we add into the M, misallocation factor, our misallocation factor is still significant price, but this future consumption, cumulative consumption, becomes the coefficient becomes insignificant. Okay, let me conclude. So in this paper, we propose a new framework to link misallocation growth and asset prices. And we show misallocation drives the low frequency components in the area growth. Because of this, it can explain asset returns as a powerful macro factor. It's a non-trivial result. And in the model, we show misallocation is a sufficient statistic that captures this G effect of heterogeneous firms, and it can empirically can be used as an instrument that predict this latent long-run consumption growth. Thank you.